Hello, I'm very happy to welcome all of you to today's online session. Thank you for your choosing to learn with me, and already I showed your commitment to success. Before we begin, I want everyone to feel comfortable and ready to participate in this lesson. Learning is not just about listening, but it is also about thinking, asking, and sharing ideas. Let me ask you some questions. Have you ever wondered how the light can remove the electron from the matter? That is exactly what we are going to explore today. Something very interesting, which is called the photoelectric effect. By the end of this lesson, you will be able to understand how the light behaves like particles and explain how electrons are emitted. And also you will be ready and you will be solve the related question very easy. During this lesson, feel free to ask a question. Share your ideas share the ideas to your colleagues. Try to answer when I ask. Remember, there is no wrong answer when you are learning. Let us make this lesson active, interesting, and enjoyable together. Are you ready? If yes, thank you. So we can begin with our journey to the electric effect for the explaining what is photoelectric effect. Actually, the photoelectric effect is a fundamental phenomenon in the physics where electrons are emitted from the surface of the matter when light of the certain frequency shines on it. This is the effect demonstrates that electron does not behave only as the wave, but also as the particles called the photons. When light strikes on the matter surface, it transfers its energy to the electrons in the matter. If the energy of the light is sufficient, some electrons gain enough energy to escape from the surface. Only the most important aspect of the photoelectric effect is the concept of the threshold frequency. Every matter has the minimum frequency of the light required to eject the electron from its surface. If the frequency of the incident light is below of the threshold, no electron will be emitted. Regardless of how the intense of the light is. This was surprising the result because classical physics predicted that increasing the light intensity should increase the energy transfer. But by experiments showed that frequency, not intensity, determine whether electrons are emitted. The Einstein explained that phenomenon by the proposing that light energy is quantized and comes in the package which is called the photons. Each photon has the energy given by the equation where we have the E, which is equal to H times F. This H is represent the Planck's constant, while the F is the frequency of the light. When the photon hits on the electron, its energy is used in two ways. The part of it is used to overcome the work function of the matter, which is the energy needed to release the electron. and the remaining energy become the kinetic energy of the emitted electron. This relationship is expressed as H times F, which is equal to work function plus kinetic energy. Another key observation is that the emission of the electron is instantaneous. As soon as light of the sufficient frequency hit on the matter, electrons are emitted without any delay. Increasing the intensity of the light increases the number of the emitted electron, but does not increase their kinetic energy. On the other hand, increasing the frequency of the light increases the kinetic energy of the emitted electron. The photoelectric effect has many practical applications in the modern technology. It is the working principle behind of the device, such as the solar panel, which convert the sunlight to the electrical energy, as well as the photocell, light sensors, and automatic switching system. Overall, the electric effect played a major role in the development of the quantum physics and helped the scientists to understand the nature of the light as the both wave and particles. So thank you for this reason. So we have the many questions about this photoelectric effect. So you can follow our channel for getting more knowledge about this one, and even for the other materials. But I thank you for your time. Thank you for your participation and so on. Thank you. For more understanding, so you can use this Fate simulation for understanding the what is the photoelectric effect. So here firstly we have this line where we have the different metals, so you can choose which one you want to use. And here we have the intensity line, so you can increase the intensity. You see when you increase the intensity what will happen. And here we have the line with the wavelength and the energy, as well as you have the lower wavelength, we have the higher energy. And once we have the higher energy, it means that you have the lower wavelengths, because the energy is inversely proportional to the wavelength. So when you increase, when you move from light left to the light, we are increasing the wavelength. So also the electromagnetic radiation are the changing from UV to infrared light. So you see here we have the invisible light, we have the other kind of the electromagnetic radiations. So what will happen if we are in the ultraviolet light? Then you increase the intensity. As you see, as we increase the intensity, here we have the light which is the shine on the heat to this metal. After hitting on this metal, you see the electron will start to be emitted. After to be emitted, as well as we changing the electromagnetic radiations for the changing the wavelength, you see the electron will be immediately to be not emitted. As well as we go in the infrared light, you see the electron will not be emitted. So it means that when we have the higher energy, have higher energy, the electron will be emitted. So as well as when you increase the intensity, you see what will happen.